permafrost is the permanently frozen ground that exists across the Arctic. And this image illustrates permafrost that is thawing. It's quite a dramatic example of it, and you have a person in the foreground there for scale. And the arrows here are meant to illustrate how the feedback mechanism we have, whereby global warming thaws the permafrost. The ground collapses, organic material that has been frozen for millennia becomes available for microbes to start basically eating up the old frozen plant remains and so on. And as a byproduct, these microbes produce carbon dioxide and methane, which then warms the climate, and you have a feedback mechanism to even more warming. And of course, permafrost losses, they are accelerating today, but this is something that has been occurring since the start of the pre-industrial. So this map illustrates the loss of permafrost that models project have occurred since the pre-industrial, with the 1 degree warming of the climate. So the dark red shows complete loss of permafrost, and the lighter colors show a gradual thaw of permafrost. But unfortunately, we have seen quite a strong increase in this thawing trend just in the last decades. And here, so you can just perhaps go back and forth a little bit between these slides, that they illustrate the gradual but actually very rapid thaw that we can observe via satellites and models. And as you go back and forth here, you see that this is from 2003 down to 2017, and there's been a very substantial loss of permafrost during these years. And it is accelerating even more in the past few summers with the heat waves we've had. So what happens when the permafrost thaw is accelerating like this and is emitting very substantial amounts of greenhouse gases? It's actually that these emissions are really big enough to significantly decrease our carbon budget that we have remaining to us to stay within 1.5 degrees warming or 2 degrees warming. These bar charts show the total size of the bar, shows the full estimated budget we have as per the IPCC 1.5 degree report to stay under 1.5 and 2 degrees respectively. And this pink part of the bars actually shows how much of that budget is eaten up by the permafrost alone. And the permafrost was not accounted for in the numbers that are the basis for those negotiations. So this is really an added stress to the system, and an added urgency to the whole problem, that the permafrost will actually emit even more CO2 and methane. And we do see very significant differences in how much carbon the permafrost will emit under different warming scenarios. So on the bottom right hand of the slide here, you see some numbers and some comparison, where by the end of this century, on a 1.5 degree warming, permafrost will emit roughly as much as India does today. At 2 degrees warming, it's roughly what the EU 28 countries are emitting today, and the high scenarios, warming scenarios that are up to 4 degrees by the end of the century, permafrost emissions will approach China or the US. These are really significant emissions that are projected. And another thing that is important to remember with the permafrost, it's often called the sleeping giant, and it's an appropriate analogy because it's huge areas, a lot of carbon that is affected, but it's also a system that responds slowly but inevitably. So emissions that we trigger now, they will continue for centuries after initial thaw, regardless of what happens to the warming, or even if we stop or cap or slow down the warming. The left three bars that you see here are 1.5, 2 degree and 4 degrees warming respectively by the end of this century. And these are basically the same numbers that you saw on the bar charts. But on the right-hand side, you see three bars that are a lot higher. And these bars show that even if we kept warming by 2100, the permafrost would keep responding for multiple centuries after that, even under stabilized warming at 4, 2, or 1.5 degrees. So this means that the thaw that we initiate now will really be committing several coming generations to having to combat these emissions and having to use negative emission technologies to draw them back down, even if total emissions have ceased or stabilized.